Have you ever opened a project folder and found final 2, and really final? That is a project with files, but no trustworthy memory. Git gives the project a timeline of deliberate save points. Each save point preserves a useful state, records who made it, and carries a short explanation of why it changed. You can compare moments, return to an earlier one, or share the same history with a teammate. But Git only protects work you deliberately record. Loose edits are still loose edits. Think of Git as a time travel photo album. The files are today's scene, while each committed snapshot becomes a page you can revisit. Is Git just another name for GitHub? No. Git is the version control engine on your computer. GitHub and GitLab are hosting services where teams can exchange repositories and discuss changes. A normal clone gives your machine its own project history. You can inspect old work, create new save points, and switch branches without a network connection. The story began in 2005 when Linus Torvalds and the Linux kernel community needed a fast, distributed replacement for BitKeeper. The important idea is independence. Your local repository is complete enough for everyday work. Connect to a host when you're ready to fetch someone else's history or share your own. When you save a change, does Git copy the entire project again? Logically, Git records a complete project snapshot, but unchanged content can be reused. Imagine photographing our tiny recipe after each meaningful improvement. The first picture has the basic ingredients. The second adds cooking steps. The third adds fruit. Each picture describes a complete, recoverable state, and each new picture remembers the one before it. That parent link turns isolated snapshots into history. Underneath, Git stores content efficiently and may compress similar data. So the mental model is not a warehouse of wasteful folder copies. Keep the simple model. A commit is one project snapshot connected to its parent in a growing graph. How does an ordinary folder become a Git repository? First, Git needs the name and email that should appear in future commit records. Those values describe authorship. They're not your hosting password. Then you enter the tiny recipe folder and initialize it with a main branch. Git creates a hidden database inside that folder. Your visible recipe stays where it is, while the hidden area holds objects, references, configuration, and the staging index. Nothing has been uploaded, and no file has been committed yet. You have only given the folder the machinery to remember future snapshots. Initialization adds project memory. It does not create the project's first memory. Where does it change while you are working on it? Git uses 3 places, and confusion disappears once you name them. The working tree is your desk, where you freely edit the recipe. The staging area is the camera frame. It holds the exact version selected for the next snapshot. The repository is the album, where committed snapshots become durable local history. Adding a path copies its current content from the desk into the frame. Committing records the frame, not every loose edit on the desk. The short status display shows both comparisons, so one file can even have stage changes and newer unstaged changes. Edit on the desk, stage deliberately, then commit to history. How do you turn a messy afternoon into one trustworthy memory? First, inspect the recipe changes and decide the single idea this snapshot should explain. The ingredient update and cooking steps belong together. A scratch note does not. Stage only those related changes. Then inspect the stage difference, because the staging area is your proposed snapshot, not a waiting room. If anything surprises you, adjust it before saving. Finally, write a message that explains the purpose. Add the tomato soup recipe. Git records exactly the reviewed snapshot, while the scratch note stays unfinished. A precise commit is small, intentional, and easy for your future teammate to understand. Which question are you really asking Git? One command tells whether the tiny recipe has tracked, staged, or untracked changes. A second reveals the exact unstaged lines, so you can inspect work still outside the proposed snapshot. A third compares the staged snapshot with the latest commit. That is your final review before saving. The fourth walks through earlier commits, showing their order, short identifiers, and branch labels. These views are not redundant. Status summarizes Differences explain, the stage comparison previews, and history tells the story. When something feels confusing, name the question first. Then choose the view that answers only that question. Where does a commit actually live? Not as a zip copy of your project. Git writes small content addressed objects. A blob holds file contents without the file's name. A tree pairs names with blobs and subtrees, like a directory map. A commit points to one root tree, its parent commit, the author, time, and message. Git derives each object's identifier from its contents. Change one byte, and that identifier changes. The new tree and commit then point to the new object. Unchanged content can be reused. So Git's history is a linked graph of content address snapshots, not piles of duplicated folders. What is a branch, a copied folder, or something smaller? It is just a movable name pointing to one commit. The head pointer tells Git which branch is currently checked out. Create the spicy branch, and both names initially point to the same recipe snapshot. Make a commit there, and only the spicy name moves forward. The main name stays behind. Switch back, and the head pointer attaches to main, so your working files match that branch's snapshot. This tiny pointer model explains why branches are cheap, fast, and safe to create. You're naming alternate lines of history, not duplicating the project. How can two correct lines of work become one history? Start with both branches at the same recipe. Main clarifies the simmer time, while spicy adds a chili option. Because each branch moved, their histories diverged. Ask it to merge while main is active. Git compares both tips with their shared ancestor, combines compatible changes, and creates a new commit with two parents. That commit preserves both routes through history. If only the other branch had moved, Git could simply move main forward. That is a fast forward. A merge does not erase either branch's work. It creates a new snapshot that joins their ancestry. What should Git do when two branches change the same sentence differently? It cannot guess your intent, so it asks a question called a conflict. In Tiny Recipe, one branch increases the salt while another reduces it. Git places both candidates in the working copy and pauses the merge. You inspect the surrounding recipe, choose one version or write a better combined version, then mark the file resolved and finish the commit. The conflict is not corruption, and neither side automatically wins. Read before deleting the markers. Test the recipe after resolving it. Teach it back. A conflict is Git refusing to invent your decision. How can two copies of Tiny Recipe cooperate without becoming one shared folder? Imagine them as independent notebooks that can exchange pages. Your local repository owns its branches and working files. A hosted repository is another complete copy. A remote is only a remembered address plus a nickname. Fetch brings new history into remote tracking references without changing your current work. Pull fetches and then integrates that history, so its second step deserves attention. Push asks the other repository to include your commits. It can refuse when histories disagree. Nothing teleports. Git exchanges commits, then moves pointers under explicit rules. Teach it back. A remote is another repository, not a cloud folder. Should you merge or rebase when two branches have moved apart? Start with Tiny Recipe. The main branch has one new snapshot, while your salt branch has two. Merge joins both paths with a new commit, preserving the real fork. Rebase copies your branch changes onto the newer main branch, creating new commit identities and a straight story. The final files can match, but the history does not. Use Rebase freely on your private work. Coordinate before rewriting commits that teammates may have copied. Merge is safer for shared history. Rebase can simplify local review. Teach it back. Merge preserves paths, while Rebase redraws your private path. How can you undo a Git mistake without losing good work? First, name the layer that should change. If you staged too much, unstitch the file and keep its edits. If your latest commit is still private, move the branch back while preserving the stage snapshot. If a commit is already shared, create a new commit that reverses it. Do not rewrite everyone else's history. If you lose a pointer, the local reference log may help you create a rescue branch. Discarding unstaged edits is the dangerous tier because they may exist nowhere else. Files become snapshots, branches point to commits, and remotes exchange them. Teach it back. Safe undo changes the smallest necessary layer.